Welcome back to this class. Now let's consider chemical properties of metals. We'll be looking at the general chemical properties of metals. Here we have about 5 chemical properties of metals. The first one here is metals are electropositive. Generally, metals, whenever they lose electrons, we have explained before that metals ionize by losing electrons. And whenever they lose electrons, they become positively charged. And that is why we say metals are electropositive. Look at examples of metallic ions, which are positive ions. Here are some of the examples of metallic ions. All of them are electropositive, starting with Na+, which is sodium ion. We have potassium ion, K+, lithium ion, Li+, magnesium ion, Mg2+, calcium ion, Ca2+, and so on. So this indicates that metals are electropositive. They lose electrons to become positively charged. And as a result of this, they become positively charged. Now, because metals are positively charged, they are usually used as reducing agents. So they are usually used as reducing agents under oxidation and reduction. So if you are asked to give examples of reducing agents, just mention metals. Metals are good examples of reducing agents. Even if you don't remember anyone, remember metals that they are reducing agents. Let's go to the second chemical properties of metal. Most metals combine with oxygen to form basic oxide. Now, the explanation of this is that anytime metals combine with oxygen, they lead to basic oxide. That is, the kind of oxide form, the compound that will be formed will be called a basic oxide. And it has the properties of a base. That's why it is called basic oxide. That is, it has the ability to turn red litmus paper blue. And this happens in the case of almost most metals, not all. Now, examples of basic oxides are the following. We have Na2O, which is sodium oxide. Then we have K2O, that's potassium oxide. We have MgO, that's magnesium oxide. We have CaO, which is calcium oxide. And we have CuO, which is copper 2 oxide. All of these are basic oxide, that is, they behave like a base. However, some other metals combine with oxygen to form amphoterics. So we call them amphoteric oxide. Such oxide behave like an acid and also like a base. That is, they share both the characteristic of acid and base. They can behave like an acid or behave like a base. Examples. Examples are zinc oxide, lead-2 oxide, and aluminum trioxide. So these three are common. So they behave like acid and base. Let's consider another chemical property of metal. Metals combine with chlorine to form electrovalent chlorides. What do we mean by electrovalent chloride? So this is a kind of compound of chlorine in which there is complete transfer of electron from the metallic ion to the chloride, from the metallic atom to the chloride atom. So anytime there is transfer of electron in a particular chemical combination, such chemical combination is known as electrovalency. For example, when sodium combines with chlorine, we have sodium chloride. So in this compound, which is sodium chloride, there is a complete transfer of electron from the valence shell of the sodium to the chlorine atom, to the valence shell of the chlorine atom. Now, consider this image. This is the sodium atom, and this is the chlorine atom. Initially, sodium is having 11 electrons in its shells. So the outermost shell of sodium contains only 1 electron. Now, this chlorine atom also has 7 electrons in its outermost shell. And the total electrons that it has in all of the shell make up 17, while the outermost shell only has 7. Now, this excess electron that we have in the atom of sodium, the outermost shell electron of sodium, will be transferred to the chlorine shell, outermost shell, meaning that chlorine needs 1 to complete 8 stable octet electronic configuration, octet state, while sodium is already filled up and having 1 extra. So the 1 extra that we have will be transferred to the chlorine atom. Thereby, the resulting compound will become sodium chloride. So at the end of the day, the atom of sodium becomes an ion, which is a cation. So we don't have the outermost electron anymore in the sodium. So we are left with 2,8. And then in the chlorine atom, we now have 2,8,8. That is, the 3 shells are now filled up. So any kind of compound that is formed in this manner is known as an electrovalent compound. And this is how one of the properties of metal. They combine with chlorine to form an electrovalent compound. Let's go to the next property. They form metallic hydrides that are ionic. First, metallic hydrides are compounds that are formed from the combination of a metal and hydrogen. So hydrogen will always be the second element. So it is always a binary compound. That is, a compound that contains two elements. One will be metal and the second will be hydrogen. That is, the first will be metal and the second will be hydrogen. Hydrogen will always be the last. So that will give us a metallic hydride. We have several examples of metallic hydride. Look at the following. Examples of hydrides are the following. We have NaH, which is sodium hydride. This is Kh, potassium hydride. MgH2, this is magnesium hydride, and this is calcium hydride. So now, each one of these are ionic. Why do we call them ionic? Ionic compounds are also known as electrovalent compound because there is complete transfer of electron. So look at sodium hydride, for instance. There is a complete transfer of electron, the outermost electron from the sodium atom to the hydrogen atom. That makes it electrovalent or ionic. So this is a good example of hydride, sodium hydride, and this is how the chemical combination takes place. Generally, hydrogen, the oxidation number of hydrogen in all hydrides is always -1, that is negative. But in every other compound, it is always +1. That's one of the rules of oxidation numbers. So let us go to the next property of metal. Another property is that they replace hydrogen in an acid if more electropositive than hydrogen. So generally, when metals react with acid, they are going to displace the hydrogen ion. They will replace the hydrogen in an acid. But this is only possible if the metal is more electropositive than hydrogen. Now, consider the activity series on the screen. Now, this is the position of hydrogen in the activity series. Those metals that are higher above hydrogen in the activity series, they are more reactive than hydrogen. While those that are below, they are less reactive than hydrogen. The most reactive metal in the activity series is potassium, and the least is gold and platinum. So those ones above, they are highly reactive, while those ones below, they are highly unreactive. So now, if any one of these metals above in the activity series combine with an acid, they will displace the hydrogen ion away from the acid and replace it. So that is why we said that metals replace hydrogen in acid if they are more electropositive than hydrogen. Let's take, for instance, consider the chemical equation above. Now, you can see that sodium is reacting with tetraoxide 6 acid. Now, if you consider the activity series, you will see that sodium is higher above hydrogen in the activity series. This is where sodium is found. And here is the position of hydrogen down the series. So any reaction between sodium and an acid will lead to the displacement of the hydrogen ion, just like it happens here. So the sodium atom replaces the hydrogen atom and displaces it. Hydrogen comes out as hydrogen gas in this reaction. So, and this produces sodium tetraoxide 6, which is a salt, and the hydrogen is liberated as gas. So, and this is how it happens for other metals too, that are higher than hydrogen in the activity series. So with this, we are able to treat some of the chemical properties of metals. Thank you.